Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about multiplication and division with surds. Now, in order to get going, I'd like you to pause the video and evaluate each of these. Right, the square root of 4, you should have got 2. The square root of 25, you should have got 5. The square root of 4, which is 2, multiplied by the square root of 25, which is 5, and therefore you should have got the answer 10. Now what happened if you did the square root of 4 times 25, the square root of 100, you also would have got 10. That's something I want you to take note of. The cube root of 8 is 2. The cube root of 125 is equal to 5. The cube root of 8, which we just said is 2, multiplied by the cube root of 125, which we just said is 5, is 10. And what's the cube root of 8 multiplied by 125? Well, that would be the cube root of 8 multiplied by 125 is 1000, and the cube root of 1000 is 10. Now, what am I trying to show you? What I'm trying to show you is the square root of 4 times the square root of 25 is the same as the square root of 4 times 25. So what you can do is when you have two square roots multiplying together, you can just put one square root over the whole thing and just multiply the numbers together. And the same applies for a cube root, and this is going to be really useful to us. Let's see if it works for division. Pause the video and work out all of the following. The square root of 100 is 10, right? The square root of 4 is 2. Now the square root of 100, which is 10, divided by the square root of 4, which is 2, will give us 10 divided by 2, which is 5. Now let's see if that's the same as the square root of 100 divided by 4. The square root of 100 divided by 4 is the square root of 25, which is 5. It's looking like this is also working for division. Let's check for cube roots. The cube root of 512 is equal to 8. The cube root of 64 is equal to 4. The cube root of 512 divided by the cube root of 64 must be 8 divided by 4, which is 2. Let's check this is the same as the cube root of 512 divided by 64. The cube root of 512 divided by 64, I'll have to check that one, I'm afraid. 512 divided by 64, 8. So this is the cube root of 8, which also is 2. So yes, this little trick also seems to work with division. If you have a square root of a number and you divide it by the square root of another number, that's the same as the square root of the two numbers divided. And the same thing applies for cube roots. Let's check if we can do this with addition. Pause the video and try and work out the following. The square root of 16 is 4. The square root of 9 is 3. The square root of 16, which we just said is 4, add the square root of 9, which we just said is 3, gives us 7. And the square root of 16 plus 9 is the square root of 25, which is, oh look, 5. That is not the same as this. Okay, that's interesting. So when you have the square root of a number added to the square root of a number, you can't just say that's the square root of the two numbers added together. That's really important there. So it's not working for addition. Let's check whether it works for subtraction in the case of a cube root. The cube root of 64 is 4. The cube root of 8 is 2. Therefore, the cube root of 64 is 4. Take away the cube root of 8 is 2. Leaves us with the answer 2. Is it the same as this? The cube root of 64 take away 8, that would be the cube root of 56. Well, trust me, the cube root of 56 is not 2. We can type it in the calculator. In fact, I think it's going to be a surd. And look, indeed it is a surd. So the answer there is 3.8. I'm just going to put ... and they are not the same. So there's some very important lessons to be learnt here, and let's try and formalize these on the next page. There is a multiplication and division rule with surds or square roots. It's brilliant for us, and what happens is if you take the square root of a number and multiply it by the square root of another number, that's the same as the square root of the two numbers multiplied, i.e. the product of the square roots is the square root of the products. For example, the square root of 2 multiplied by the square root of 8 is going to be the square root of 16, which is really useful to us. And similarly, it works with division. The square root or cube roots, these apply there as well, of a number divided by the square root of another number is the same as the square root of the first number divided by the second number. Or another way of saying it is, the quotient of the square roots is the same thing as the square root of the quotient. So let me give you another example of that. Let's say the square root of 32 divided by the square root of 2 is going to equal the square root of 32 over 2, which is the square root of 16. And that's going to be really useful. And we are going to use these over and over and over again, this multiplication and division rule, both ways. Sometimes we're going to have a square root of two things times together and we need to break them up. Sometimes we're going to have the square root of something times the square root of something else and we need to combine them. And exactly the same with division. But do not fall for the trick. This does not work with adding or subtracting square roots. And students think it does. For example, a common mistake that students say is things like, I don't know, the square root of 5 plus the square root of 11 is going to be the square root of 16. Trust me, it isn't. If you type it on that and that added on your calculator, you do not get 4. So with addition and subtraction, just be super careful. Okay, let's apply the multiplication and division rule to some scenarios. Pause the video each time and try it first. So the square root of 2 multiplied by the square root of 8 is going to be the square root of 2 times 8, which is 16, and we know the answer to that, it's 4. The square root of 5 multiplied by the square root of 20 is going to be the square root of 5 multiplied by 20, which is 100. The square root of 100 is 10. The square root of 2 multiplied by the square root of 32 is going to be the square root of 2 times 32, which is 64, and the square root of 64 is 8. The cube root of 2 multiplied by the cube root of 13.5 is going to equal the cube root of 2 multiplied by 13.5, which is 27, and the cube root of 27 is 3. And there you go, a nice application of the multiplication rule with surds and square roots. Let's try another one. Division this time. The square root of 45 divided by the square root of 5 is going to be the square root of 45 divided by 5, which is 9, and the square root of 9 is 3. Now this is just another way of writing division. It means exactly that divide sign. Here we're going to say the square root of 288 divided by the square root of 2. We're going to say that's the same as the square root of 288 divided by 2, which is going to be the square root of 144, which we know the answer to is 12. The last one, the cube root of 54 divided by the cube root of 2, that's going to equal the cube root of 54 divided by 2, which is going to be the cube root of 27, which we know, as always, is 3. And there we go, a lovely application of the division rule with surds and square roots. What about these? Evaluate these without a calculator. Now, I bet it's tempting to say this is the square root of 36 add 64, which is the square root of 100, which is equal to 10. It's so tempting, but I'm afraid it's not right. Remember, you cannot do the same thing that we've been doing with multiplication and division with addition or subtraction. So we just got to work this out separately, and add them. Square root 36 is 6, square root 64 is 8, 8 add 6 is equal to 14. You see, it wasn't 10. And this one, steer clear of trying to subtract them. Square root of 169 is 13, square root of 144 is 12, 13 take away 12 is 1. And that is how you do addition and subtraction. Keep them separate. Could we try and evaluate that without a calculator? Well, using the multiplication law, this would be the square root of 9 multiplied by a quarter. And 9 multiplied by a quarter is 9 quarters. And we could say the square root of 9 divided by 4, well, that's the same thing as the square root of 9 over the square root of 4, using the division law but the other way round. And that's going to be the square root of 9 is 3 over the square root of 4 is 2, and there we go, the answer is 3 over 2. One last question for us on this. Evaluate without a calculator the following. So I would say that's the same thing as the square root of 27 over 12. I would then try and simplify that fraction. I could divide top and bottom by 3. So this is going to be the square root of 9 over 4, and therefore that's the square root of 9 over the square root of 4, which I know is going to be 3 over 2 again. And that's it for this video, multiplication and division with surds.